Good morning, students. Today we will discuss about the preparation of oxygen of group 16, the first member. So let's we discuss about the preparation of oxygen. Preparation of oxygen is at first we use by heating certain oxygen rich metal oxides. Certain oxygen rich metal oxides. For example, if we have silver oxide, and whenever it is heated it forms silver and oxygen. Similarly, if HgO undergoes to thermal decomposition, it will form oxygen. So it is the easiest method to obtain oxygen from oxygen rich metal oxide. And next preparation will use by the thermal decomposition of some oxygen rich salts, and the most common oxygen rich salt use KClO3, potassium chlorate when heated in presence of catalyst MnO2, formation of potassium chloride and oxygen takes place. In fact, this method is used for the laboratory preparation. The third method, by the decomposition of hydrogen peroxide. As we know, hydrogen peroxide undergoes to disproportionation reaction and it will form H2O and O2. So these are the simple method we used for preparing oxygen. Preparation of pure oxygen. How can we prepare pure oxygen? So student, it is very easy method by the electrolysis of barium hydroxide using nickel electrodes. So these are the simple method for preparing oxygen. Let's we discuss about the properties of oxygen. So at first, properties of oxygen, we will discuss about the physical property, then after we will discuss the chemical property. So students, most common physical property we study about the O2. It is paramagnetic in nature, slightly soluble in water, and it has 3 isotopes. Oxygen 16, 17 and 18. 3 isotopes and are stable in nature. Stable isotopes. These are the stable isotopes. Now, chemical properties. Chemical properties. At first, we will discuss about the reactivity of dioxygen. Reactivity of dioxygen. So, very stable in nature. Very stable because bond dissociation enthalpy is quite high, because bond dissociation enthalpy is quite high, because we know that there is a double bond present in oxygen molecules, and due to smaller size and a strong bond between them, so it has lot of energy required to break this bond. So their bond dissociation enthalpy is quite high, so that it is stable in nature. And first characteristic, we will discuss the reactivity of oxygen with metal. What happens when dioxygen reacts with metal? As we studied in the general property of group 16, when oxygen reacts with metal, it will form oxides, and in which oxygen require -2 oxidation state. Suppose iron treated with oxygen, it will form ferric oxide. So you can balance it, student. In your notebook copy, we will discuss reaction. Now next, reaction with non-metal. Reaction with non-metal. Oxygen reacts with number of non-metals to form non-metallic oxide, nitric oxide. And suppose we have phosphorus, it treated with phosphorus, it will form phosphorus oxides. Number 3, reaction with compound. Reaction with compound. Number first, with ammonia. Whenever the oxygen react with ammonia, when NH3 treated with oxygen at high temperature, suppose it has 1100 Kelvin temperature and presence of catalyst, it will form nitric oxide and water. Nitric oxide and water. With sulfur dioxide, it with sulfur dioxide plus oxygen at high temperature 723 Kelvin, and here we use also catalyst, either platinum or vanadium pentoxide, so it will form sulfur trioxide. This method is used for preparing sulfuric acid commercially or by contact process. With hydrogen chloride, this reaction will help you to complete the reaction in inorganic chemistry. So students, practice it, remember it. Oxygen in presence of CuCl2 and 700 Kelvin temperature. No need to remember or by heart to this temperature, only heating sign we can use for this reaction only. So in this way you can only show the reactivity of oxygen with the compound. What happens when oxygen react with ammonia? What happens when oxygen react with sulfur dioxide? What happens when oxygen react with hydrogen chloride? In this way, suppose if there is given carbon disulfide also, suppose carbon disulfide. So student, at first write down the reaction CH2 carbon disulfide plus oxygen, and when it treated to each other it will form CO2, carbon dioxide and sulfur dioxide. Balance this equation, and at last with hydrocarbons made with methane, suppose we take methane here, hydrocarbons, so CH4, everybody know that this reaction, whenever the hydrocarbon oxidize it will form CO2 and water, and this reaction is highly exothermic in nature. We all know that. Suppose 890.0 kilojoule per mole energy release. So in this way you can show the number of reaction or reactivity of oxygen. We study about the properties of the first member of group 16. Now next we talk about the oxides of first group of member, means oxides. How many types of oxides formed by the first member of this group? So we talk about the simple oxides. Simple oxides. So student, it will form 3 or 4 types of oxides. It forms acidic oxide, neutral oxides, basic oxides, amphoteric oxides, and mixed oxide. So many oxides are formed by this first group of, means oxygen form so many oxides. For example, at first we talk about the acidic oxide. Only with example I am going to explain. Suppose acidic oxide, non-metallic oxide is known as this acidic oxide, because whenever this non-metallic oxide dissolve in water it will form acid. Everybody know that. So, CO2 when treated with H2O it will form H2CO3. So this is the acidic oxide. Next one is basic oxide. Basic oxides. Obviously metallic oxide is known as a basic oxide because when metallic oxide treated with water or dissolved in water it will form base. Number 3, neutral oxides. Neutral oxides, which means no any characteristics shown by this type of oxide with litmus paper or another test method. For example, carbon monoxide, N2O, nitrous oxide, nitric oxide, and water also is known as a neutral oxide. Next one is a amphoteric oxide. Amphoteric oxide. Everybody know that amphoteric oxide are those oxides which treated as acid or base, both. Suppose we have aluminum oxide, and whenever it treated with HCl it will form a complex compound like aluminium H2O whole 6 3 plus aqueous medium and chloride. So balance it, 6 chloride will be plus 6 chloride. And what will be the name of this compound? Write down the name of hexa aqua aluminium 3 ion. In coordination chemistry, we will study about the naming of complex compound, how will we write the naming of complex compound. And here aluminum oxide is behave as a base, means basic. So balance this equation 6HCl, and it is also in a aqueous medium. Next one is aluminum oxide when treated with sodium hydroxide. Aluminum oxide when treated with sodium hydroxide. So student, NH2O. Here we also use water, 9H2O. Suppose write down the balance equation, student. So whenever aluminum oxide treated in basic medium, so it will form Na3 Al OH whole 6 aqueous. What will be the name of this compound? So it will sodium hexa aqua aluminate 3 ion. So write down the name of this compound: sodium hexa, what is known as aqua. How many aqua? Hydroxo. So sodium hexa, which is known as hydroxo aluminate 3 ion. Aluminate 3 ion. So here aluminum oxide is behave as a acidic oxide, 3H2O. So in this way you can give the example of different types of acidic oxide. One more oxide is mixed oxide. I am right. Mixed oxide. Mixed oxide, students, you all familiar with this, the formula Fe3O4, Pb3O4, Mn3O4. So it is made up of ferrous oxide and ferric oxide. Ferroso-ferric. Similarly, it is also PbO and PbO2. So Pb3O4. So in this way you can Pb3O4. So in this way you can prepare the number of, it is called the red lead. So in this way you can give the example of so many oxides: acidic, amphoteric, basic, neutral, mixed, so on. Let's we discuss about the properties of oxides in a group or in a periods. So student, at first in a group, for example, if we talk about the group 2 or group 3 or group 1 or group 2, so in a group basic strength increases. Basic strength increases because metallic character increases when we move top to bottom. For example, in a group 2, let's we discuss about the group 2. The first member is beryllium oxide, then magnesium oxide, then calcium oxide, then strontium oxide, and then barium oxide. So when we move top to bottom in a specific group, or in the case of group 2 or group 1, the basic strength increases because their metallic character increases. But when we move left to right in a period, the acidic character increases because non-metallic character increases. So when we move left to right in a period, basic character decreases and acidic character increases because non-metallic character increases. So this is a simple characteristic about the oxides of group 16. What happened when we move left to right in a period? The character of oxides, basic character of oxide decreases and acidic character of oxides increases. When we move top to bottom in a group, the basic character increases because metallic character increases. So let's be talk about the next topic, that is called the isotopes of oxygen, which is called ozone. Ozone. It is the isotopes of oxygen. Isotopes of oxygen. And students, we all know about the existence of ozone in the at the Earth surface, where the ozones are formed, where the ozones are present. So students, the ozones are present uppermost. Suppose it is the Earth surface. So about 20 kilometer from the Earth surface. This is the Earth surface. So from 20 kilometer above the Earth surface, so ozone is present. So it is known as the stratosphere. Means this region is known as stratosphere. And here the action of ultraviolet radiations on dioxygen, ozone is formed. So oxygen is present here, and whenever it treated with ultraviolet rays of sun, so it becomes ozone, and it is present in the stratosphere region about the 20 kilometer above the Earth surface. So the main function of ozone, it protects the Earth and it inhibits from the harmful radiations from the sun. If there were no ozone layer, more ultraviolet radiation will reach the Earth surface, causing much damage to the plants or animals' life. So students, how and what are the agents which deplete the ozone layers? So depletion of ozone layer. So most dangerous species present in the atmosphere, this is the nitric oxide, this is the chlorofluorocarbon, means flights of supersonic aeroplanes, nuclear explosion. Lightning mainly releases nitric oxide into the atmosphere. These are the harmful chemicals, harmful species which damage the ozone layer in the stratosphere region. So this is the these agents are causes for the depletion of ozone layer. Next, we discuss about the preparation of ozone layer. How can we prepare ozone? So let's see the preparation. Ozone is prepared when the silent electric discharge given to the oxygen, so that the formation of ozone layer takes place. Ozone compound form here, not, and it is the endothermic process. 142 kilojoule per mole energy has to be given. Silent electric discharge means, suppose we have two electrodes, and in between the oxygen is passes. So somewhat charge is conducted by this oxygen and it converted into oxygen. So there will be no explosion take place. Suppose this electrodes, suppose they touch to each other, there will be explosion or spark takes place. So these two electrodes kept separately from the few distance, and oxygen is passed through this electric discharge. So silent electric discharge given to this oxygen, so formation of ozone takes place. What is the structure of ozone? Ozone contains 3 atoms of oxygen and it has bent shape and hybridization of oxygen is sp2. Let's we discuss about the structure of ozone. Suppose this oxygen form double bond this oxygen and it has 2 lone pair, and this oxygen 1 2 3 4 5 6. So this oxygen is make coordinate bond with this oxygen, so it requires positive charge and it requires negative charge. So resonance structure takes place. Suppose here it will form plus with 2 electrons, and here the double bond oxygen forms with 1 2 3 4, here 1 2 3 4. So resonance hybrid structure is like this, So student, this is the structure of ozone. It is the bend shape and the oxygen is a sp2 hybridizing nature. Next we talk about the properties of ozone. Ozone behaves as a powerful oxidizing agent. So as a oxidizing agent. Oxidizing. It behaves as a powerful oxidizing agent. Oxidizing agent because ozone is an endothermic compound. On heating, it readily decompose to give dioxygen and nascent oxygen. Ozone, whenever the heat is given, it forms dioxygen and nascent oxygen. Since nascent oxygen is very reactive, so it acts as a powerful oxidizing agent. Let's see example. Ozone, when decomposed, it will form O2 plus nascent oxygen, and lead sulfide take this nascent oxygen, get converted into PbSO4. Now balance this equation. This is 4 and this is also 4. So in this way you can cancel this common, and formation of PbS plus 4O3, 4 ozone to form PbSO4 plus 4O2. This is the important characteristic of ozone, in which it behaves as a powerful oxidizing agent. Next question is how ozone is estimated qualitatively? So students, let's see. How ozone is estimated qualitatively. Not qualitatively, quantitatively. So whenever ozone is treated with excess of Ki solution, see here, when Ki treated with excess aqueous form of Ki treated with ozone, it will form KOH plus O2 plus iodine. So let's balance this equation to Ki, and how much iodine is formed during the reaction of ozone and Ki. It is estimated by titrating with hypo solution S2O3 minus 2. It is called the hypo solution, and it treated with iodine, so it will converted S4O6 2 minus and 2 iodide ion form. So how can we know that how many ozones are estimated qualitatively? So here, by the balance equation, we use, if 1 mole, suppose if we use 1 mole of ozone, 1 mole of ozone gives 1 mole of iodine. How can we know that 1 mole of iodine is formed from 1 mole of ozone? So for knowing this iodine, we will take known concentration of hypo solution. So here we see that this hypo solution, 2 moles of hypo solution get converted into S4O6. So it gives 2 moles of S2O3 minus 2. So it converted into S4O6 is indicate that 1 mole of iodine is formed because 2 moles of hypo solution is used, because it converted into S4O6. In this way we can estimate qualitatively the ozone. I am again explaining how ozone is estimated quantitatively. So here student, whenever this reaction is proceeded and iodine is formed, suppose Ki when treated with ozone, the yellow color of iodine is formed. This indicates that the formation of iodine takes place. Not all the potassium iodide get converted. Few potassium iodide get converted into iodine, and rest will form in this solution. So this iodine is formed, is treated with known solution of hypotitration. With the titration method, we can find out the number of moles of iodine, because it indicates how much ozone is used to form 1 mole of iodine. So when the hypo solution is treated with iodine, hypo solution get converted into S4O6. So by knowing this much formula, by knowing this concentration, we can find 1 mole of ozone gives 1 mole of iodine, because here use of 1 mole of iodine only. So means 1 mole of iodine is formed by 2 moles of S2O3 minus 2. So in this way you can find out the ozone estimated quantitatively. This is the important questions related to the ozones. Try to understand. So students, ozone is thermodynamically unstable as compared to oxygen, resulting in liberation of heat, and as in increase in entropy, so there is 2 factor in force each other, resulting large negative gives free energy. So write down the topic, why decomposition of ozone takes place as fast, which is the causes of oxidizing nature. So student, ozone is thermodynamically thermodynamically unstable as compared to oxygen, result in liberation of heat. Delta H is negative. When the ozone decomposes, the energy release, and as increase in entropy because ozone when decomposed it forms O2 plus Nassen something. So delta S becomes increase, delta S become positive. So these two factors, so student, increase entropy, that is delta S is positive. So these two factors reinforce each other, resulting in large negative Gibbs free energy change for the decomposition of ozone to oxygen. So this is the completion of first family member of oxygen, their preparation and properties, and their isotopes ozone, their preparation and properties. Color of ozone is pale blue color. So it is written in your NCERT book. So go through the NCERT book and their property, learn it, their property, and write down the all questions related to this topic. In the next video we will study about the sulfur, the second member of group 16.